A demo of how a user can go through cross-chain GK KYC based process to whitelist his wallet to a smart contract deployed on any Cosmos chain. So let us assume that there is a DApp which provides services like airdrop, launchpad, dexes, etc. But only to the peoples of certain list of countries. But what we actually going to prove is that the user is not a citizen of blacklisted countries, because that is easier to prove, right? So how it works is basically the user comes to this dApp, it goes through a KYC process where the user provides all his personal details like name, age, country, etc. The KYC issuer verifies all these details and issues a verifiable credential to the user. The user then generates a zero knowledge proof in his wallet of citizenship, and then provide the proof to the whitelisting pool contract. The whitelisting pool contract finally connects with Hypersign blockchain to verify the zero knowledge proof over IBC and gets the result either true or false in the form of acknowledgement. Once it gets the acknowledgement, it just whitelists the wallet address of this user. Yeah, so 3 steps: credential issuance, proof generation, and proof verification over IBC. But before I jump into the technical details of this demonstration, let me show you the demo first. Let me explain the setup here. We have Hypersign chain where the GK verifier contract is deployed. We have a WASM-D chain, a demo blockchain where our whitelisting pool contract is deployed. We also have Hermes here, which acts as a relayer, which helps into the IBC transactions from chain 1 to chain 2 and vice versa. So let us jump into this user interface, right? This is very basic user interface that we prepared quickly, where a user can connect his wallet. Don't worry that why I am starting the flow with EVM based wallet is just to show you that this decentralized identifier is also capable of holding the EVM based chains. So what user will first do is user will first go through the KYC process. So let us just go through a dummy KYC process that we have here. So I'll just select a dummy identification card and request my credential. So let's just wait for credential to be issued. So we have requested our credential, the data is given to the issuer, and the issuer is issuing us the credential after verifying all this data. So as you can see, credential is issued to me. Now we can go ahead, and the data which was present in this credential is basically some dummy data like my name, country, and so on. So now you can go ahead and generate a zero knowledge proof for your citizenship, right? So we'll generate a zero knowledge proof of citizenship. So the proof looks like this, and now we are ready to submit this whitelist zero knowledge proof to the whitelisted contract. Yeah, so let's go ahead and try to submit. So as you can see, when I'm trying to submit this proof, I'm actually submitting to the contract which is deployed on WASM, which means the whitelisting contract, right? So let us try to approve this and wait. So there is one more manual step that we need to do for Hermes to really work, because Hermes sometimes does not relay the packet automatically. So what we have to do is we have to clear this packet. So I cleared this packet, and let's just get back to the UI and wait. So now you can see the wallet is whitelisted. I can quickly recheck. So when I try to submit the whitelist or submit the proof again, it says whitelisted already. Now that we have seen the demo of this entire flow, we can jump into the technical details of this demonstration. So we will start with the credential issuance, right? Let's assume that this is the data, the raw data that which user provides to the issuer. Yeah. So it contains age, country name, user's DID and name, for example. The issuer somehow verifies this entire information and generates a verifiable credentials by signing this data with his private key that they hold. They basically sign a root hash, the Merkle root hash of this data, and generates the verifiable credential and send it to the user. Now user has to generate the zero knowledge proof for the citizenship, right? But in order to do that, it first generates a verifiable presentation, Verifiable presentation is nothing but credential which is also signed by the user himself. This is just to prove that this is the right user to whom the credential was issued. Yeah. So now you can see the verifiable credential presentations look exactly like a verifiable credential, except that you have now two signatures here. Yeah. Now this verifiable presentation, is given as an input to the circuit, generalist circuit that we have written, along with the excluded list of countries, which is nothing but the blacklisted list of countries. Yeah. So these two inputs are given to the circuit, and the circuit itself is basically consists of various smaller circuits which goes through bunch of checks, like it checks for the integrity of the data, whether the data was tampered or not, check for if that credential was expired or not, whether it checks for the signature of the issuer, it checks for the signature of the user, and so on, and of course the membership check, and then generates a zero knowledge proof and the public signals. So these two, the proof and the public signal are the input to the verifier, GK verifier smart contract. Yeah. So we can quickly take a look on on the circuit. Like, this is a circuit that we have written, and we are using GK Snark for that, and for the circuit the language is circum, and you can see that we have written all those check here, integrity, issuance, issuer signature, membership, and holders signature check, and we have generated the generalist proof as well as the verifier contracts which we have deployed here on Hypersign. And the business contract, which is nothing but the whitelist contract, is deployed on the WASM-D chain, which we have, which I have shown you, right? So what happens after that is, as you know, that the user will submit this proof to the business contract or the service provider chain to get the proof verified from the Hypersign, and then it whitelists the user. And for that, we have a relayer called Hermes, which relays these packets from this chain to this chain and get back the acknowledgement back to the WASM chain. So that is it for this demo, and I hope you're able to understand that how a user is able to do on-chain KYC and whitelist his wallet. Thank you very much.